Everyone, and welcome to day 2 of lesson 6.5 through 6.6. Today we are going to focus on rectangles. So similar to a rhombus, a rectangle is a parallelogram. So you will notice it has all the properties of a parallelogram that we've discussed before, but specifically it doesn't have 4 congruent sides. This time it has 4 right angles. So that's the big difference is our parallelograms and a rectangle is you specifically have 4 90-degree angles. Some other things that are important besides the 90-degree angles, which you will see happening down here because those sides are perpendicular. The other big thing is that our diagonals are congruent to each other. So RC and TE are congruent to each other. And then because of the diagonals being bisected, that means all of these baby pieces would also officially then be congruent to each other. So congruent overall diagonals, congruent pieces of the diagonals as well. So kicking things off with our example problems, we have some true and false. So are all rectangles parallelograms? Yes, they are. That is a true statement because, again, rectangles are parallelograms, just specifically with 4 right angles. Are some rectangles trapezoids? That is false, right? Trapezoids only have 1 pair of parallel sides, and rectangles, like a parallelogram, have 2 pairs. Are all parallelograms rectangles? That is a false statement. All of our rectangles are parallelograms, but parallelograms might be a parallelogram, they might be a rhombus, and maybe sometimes they're a rectangle. Last but not least, are all rectangles quadrilaterals? Yes, that is a true statement. They have 4 sides, and that's the definition of a quadrilateral. It's having 4 sides. All right, as we move on to the next page, we are told that our figure TGIF is a rectangle. So we are given the length to start that TX is 13, and we're looking to find the lengths of our diagonals T to I and F to G. Well, we know that those diagonal pieces, again, are all congruent to each other. So if T to X was 13, so is X to I. So the whole length of T to I then would be 26. And then again, if T to I is 26, from adding those pieces together, F to G, the other diagonal, has to be equivalent to that because the diagonals are congruent. In our second example, we are given T to X and F to X. Well, again, we know that all these baby pieces, TX and FX, they are all congruent to each other. So we could take 4x plus 4, set it equal to the other baby piece that we are given, and we can solve for x. Subtract 4x from both sides, we get 3x minus 23 on the right. Add 23 to both sides, and eventually divide by 3. We get x to equal 9. Now the question is asking us for the length of T to I. So if we plug back in, T to X is 4 times 9 plus 4. So 36 plus 4 is 40, which means that our other piece of the diagonal is 40. So T to I would have to be 40 plus 40, which is 80 units. Now TGI, this angle here, is going to have to be a 90-degree angle since those sides are perpendicular. And notice then on the second part, if they gave us XFT, this little angle right here, and they gave us XFI, instead of those pieces being equal to each other like they are in a rhombus, in a rectangle, our 2 little pieces have to add up to equal that right angle. So 6x minus 4 plus 10x minus 2 has to equal 90. Well, 6x plus 10x is 16x's. Negative 4 minus 2 more is negative 6. Add the 6 to both sides, we get 16x equals 96. And then when we divide 96 by 16, we get our answer to be 6. And again, we're just solving for x. All right, last example on this page, we have f to g, this whole diagonal, and then they give us xi down here. So basically what's happening is if we have these two little pieces, even though they didn't officially give us t to x, we know that those two both have to be 2x minus 1, and our whole diagonal, f to g, is 3x plus 6. So that whole diagonal, 3x plus 6, has to equal our two little diagonals added together. So combine like terms before we move things over. 2x plus 2x is 4x's. Negative 1 minus 1 more is negative 2. Now we can start moving across the equal sign, subtract 3x over, and add 2. X is going to be 8. Now we have two examples for you to try on your own. On this next page, we have given diagonals MO and NP. You are finding x. On the next page, we are given MQ and PQ. You want to solve for x and then find PN. And then the last example for you to try, not dealing with the sides this time, we're dealing with the angles. You are given PMO, and then you are given NMO, set up and solve for x. So to finish things off today, which description best fits our rectangles? Well, quadrilaterals with perpendicular diagonals that bisect opposite angles, that's actually going to be a rhombus. So that's not going to help us. Quadrilaterals with diagonals that bisect each other, that's a property of just a parallelogram, so not necessarily descriptive enough to tell us any more. Diagonals with perpendicular diagonals, again, that's the property of a rhombus. So last but not least, a rectangle with congruent diagonals would be our rectangle. Thanks everyone for watching, and we will work more with these examples in class.